Coincidences feel like whispers from the universe, but they usually speak the language of large numbers. Today we'll see why rare alignments happen routinely without magic, because big samples breed surprises and our brains insist on patterns. The core idea is this: randomness, multiplied by scale, guarantees odd stories. We remember the hits, forget the misses, and craft meaning afterward, which meant chance looks scripted. Start with the law of truly large numbers. It says that with enough opportunities, events with tiny probabilities occur, therefore you should expect the unexpected when the sample explodes. Use a school as an anchor. A calendar has 365 possible birthdays, so two strangers matching feels special, which meant you might expect it only in giant crowds. But the famous birthday problem flips that intuition. In a group of about 23 students, roughly a single classroom, the chance of at least one shared birthday sits around a coin toss, not a long shot. Scale it up. In a school of 900 students, matches aren't news. Overlapping birthdays become routine. Therefore, the right question shifts from "will it happen" to "how many times will it happen?" This logic reaches far beyond birthdays. License plates that echo your phone digits, receipts totaling the year you were born, or bumping into a neighbor on a trip to Rome each have low odds in isolation, yet life offers thousands of draws. Because we hold one outcome and ignore the many near misses, the hit looks prophetic. The truth is less mystical. The world provides enormous sample sizes every week, which meant the improbable must appear. Next, let's meet the mind's eager co-author of coincidences. Apophenia. Apophenia is our tendency to see meaningful patterns in random or unrelated data, which quickly becomes pareidolia when the patterns look like faces or forms. You've noticed faces in power outlets and animals in cloud banks. You've heard words in static and melodies in wind. Therefore, noise starts sounding like a message because our perception prefers false alarms over misses. This bias helps with survival. Better to overdetect potential signals, which meant your brain connects dots that never agreed to be connected. We stitch stories from scattered points and then defend the story as if the points arrange themselves. Sports fans do this with streaks. A player hits 3 shots and the arena believes in a hot hand, yet many streaks arise naturally from randomness. And the research has swung over the decades from skepticism to a more nuanced view that some streakiness exists, but much of what we hail as heat is noise. We do it with names. Meet 2 Emmas in 1 week and you feel the name everywhere, because attention fuels availability, and availability feels like truth. We even do it with words at the grocery store. Spot, organic, and origin on 2 different labels side by side, and a connection seems intended, which meant proximity masquerades as pattern. Now for a place where pattern hunting gets expensive: lotteries. A lottery drawing is designed to produce independent numbers, which means past patterns do not predict the next set. Look at a typical 6-number draw from a pool like 49. You can see sequences like 7, 8, 9, or clusters like 3, 4, 5, 6, and people swear the machine won't do that again. Therefore, they avoid neighboring numbers and chase gaps. But independence cancels memory. The balls don't know last week's result, which meant a repeat of 1, 2, 3, 4, 5, 6 is as likely as any other specific combination, even if it feels suspicious. Here's where data beats opinion. Millions of tickets, say 10 million in a large country, are purchased each week. And buyers favor birthdays and anniversaries from 1 to 31. Therefore, low numbers get crowded. That crowding doesn't change the odds of winning. It changes the odds of splitting, which meant if you insist on playing, picking less popular numbers only tries to protect payout size after you win, not the chance of winning at all. We often misread runs of draws. See the number 22 appear 3 times in a month, and we build a story about hot 22, when randomness often clumps, and clumps feel designed. That brings us to a softer myth born inside our devices. If a song repeats, the shuffle isn't random. Story says the app is broken. Evidence says randomness clusters. True random sequences produce streaks and repeats, because random does not promise even spacing, which meant hearing the same artist twice in 5 tracks doesn't violate probability. It advertises it. Many music players later adjusted by adding smart shuffle to spread artists and tracks apart. That makes the experience feel random while quietly biasing away from clusters. Therefore, the system sacrifices purity to match human expectation. If songs from the same album pop up back to back, your brain flags it as wrong because you expected distribution, not true randomness. But real dice produce doubles. Real shuffles sometimes yield near-ordered runs, which means surprise is the default, not the bug. All of this gives us a healthy toolkit for coincidences. When a headline trumpets a 1 in a million event, ask how many million chances existed. Because a city of 5 million over 365 days produces a lot of lottery tickets, birthdays, meetings, and weirdly timed phone calls. When a pattern leaps from noise, test it with a prediction you can fail. If the prediction fades, the pattern was probably a story, therefore you can let it go without dimming your curiosity. When your playlist repeats, remember that clumping is honest. Perfect alternation would be the real tell that someone is nudging the deck, which meant tidy randomness is often curated. Finally, let's end with a decision scenario that loves to trap confident minds. You sit at a table with two sealed envelopes. One contains some amount and the other contains exactly twice that amount. You pick one envelope at random and feel the weight, but you may not open it yet. A card says you may swap envelopes once before opening, which meant you face a simple choice that hides a paradox. Some framings claim both options sound better. If the amount you picked is A, you imagine the other envelope holds either A2 or 2A. And people argue the expected value makes swapping attractive. Therefore, your intuition tries to push you into motion. But expectations depend on how you model the unknown amounts. The trap mixes a fixed number you are holding with a hazy distribution for what could be in the other, which means sloppy assumptions manufacture an advantage that might not exist. Your challenge is to choose swap or stay and defend it in one sentence. State the principle you're using. Symmetry, expectation under a defined distribution, or framing, and keep it tight. We won't solve it here. We'll reveal it and highlight the best takes in the next Mind Maze stream. Before we go, here's the distilled takeaway. Given enough chances, the unlikely becomes inevitable, and a pattern-loving brain turns inevitabilities into prophecies. Name the sample size before you name the meaning. If this episode sharpened your sense for chance and story, subscribe for more mind-stretching journeys each week.